So there are some things that people calculate to measure variation in weights, and the why do the weights vary? I've got four reasons written here. You can design in variation in weights. In your initial sample, like PPS selection will lead to variable weights. If you want to equalize the sample sizes in like blacks and whites in a household survey, you're going to have to sample African Americans at a higher rate because there are fewer of them. So that automatically creates weights that are different, base weights. That's the under or over sampling. And if you do two-phase sampling, you want to do non-response follow-up on a selected set. That will create unequal weights. Another reason you end up with unequal weights is you got unequal response rates, unequal adjustments for non-response in different groups. And then if you calibrate, that can torque the weights around again. If you're way short for young Hispanic males before calibration, that calibration adjustment will make your weights vary even more. So, all those may be perfectly legitimate reasons for having varying weights. They're not necessarily a bad thing. They will increase the variances of your estimates. So the argument you're making is you're correcting some kind of bias by doing these adjustments. Or, you are actually improving the efficiency of certain estimates by, the implicit modeling that goes on in calibration. Now, a popular measure is this Kish design effect due to the weighting, which is, the one way I can remember it is 1 plus the REL variance of the weights, which is, a REL variance is the variance of something divided by the square of the mean. So, if this is going to be positive because it's a variance. If it gets to be too much bigger than 1, then you begin to get excited and wonder if you've done something wrong. In typical household surveys, like HRS, I think we were seeing design effective weights that were, for some groups, up 3 or so, maybe a little more than that. That's not awful. There was a reason for it, too, because we were oversampling. Now, you look at this is just the variation in the weights. It doesn't even look at the Y values, the analysis variables. Variable weights may be the right thing to get good estimates for certain Ys. So there are other design effects that really address particular Ys. And we got them in Prac Tools. There's one due to Kim Henry and Bruce Spencer, and then Cecil Chin and Keith Rust derived one that was in JSSAM a couple of years ago. Those all account for the Ys. So they'll be different for every Y. The Kish thing is just one number. It has nothing to do with the Ys. Okay, so what do you do in practice? You can do the Kish thing if you get a design effect for the weights at 10 or something, then you start to think, whoa, maybe I did something wrong. And at that point, you could compute one of these more fine-tuned design effects due to Henry or Chin Rust or Spencer, and take a look at those and see how bad those are. It would be no surprise if Kish is big, but these are less big. If you're, effectively creating weights for Ys. Okay. Any final questions before I hit non-probability sampling? Yes.
So if the non-response rates are calculated by analyst, and the specific analyst who works with the survey data, what is the need for calibration of this final weights that accounts for the non-response rate? Is there a need for that?
Let me make sure I understand the question. So are you asking what's the reason for including calibration if you've already done the non-response?
So if I'm working with the survey data as an analyst, not the survey designer, but the analyst, and I encounter some missingness in the outcome of the interest, and I'm doing the non-response weights to account for this at the top of the final survey weights. Like, is calibration or the post-stratification is the good approach?
Oh, I see.
Should I worry about calibrating my final weights that account for the old survey weights?
Yeah. So the question is, you're a data analyst. You're using a file that somebody else has prepared. It's got weights on it. But you got missing data on certain Y's.
Yes.
What do you do? The weights that you've got have probably been prepared in such a way that they project all the sample units to the full population correctly. That's regardless of the Y variables, whether they're missing or not. So if, one thing, you could calculate a weight that is specific to a Y, recalibrate, that would be legitimate. But the thing that is a lot more convenient that is usually done is impute for those missing Ys. So you can just use the same set of cases for every analysis. So that's where things like multiple imputation come in.
So you argue for multiple imputation versus non-response weights done by analysts?
Yeah, I would prefer the multiple imputation, say. It's just too much trouble to calculate weights. The nice thing about that particular method, multiple imputation, is assuming you've got some randomness in how you impute the values, multiple imputation will give you this little adjusted variance that accounts for that randomness. And it'll be correct in most situations. Plus, software at this point is available that will account for, if you got a file, two situations. You got a file you've been given to use that has got multiple weights or multiple values of those imputations, or you create them yourself. There's software that will properly account for those multiple values. Account for it in the sense of getting a standard error that reflects those multiple values. So that I think is the way to go. Okay. So there's a lot of debate out there in the profession about is multiple imputation the right way to do this? There are these other options that are out there. Multiple imputation is the easy, and as they say, you got software that'll handle it already. These other alternatives you'd have to program yourself, and there's not not the software.
Personally, I would do multiple imputation in this situation, but there is a group that I'm consulting, and there is particular missingness affects just one variable that they're interested as outcome for their paper, and they're very reluctant to go imputation route. And then I thought we can do non-response weights on this variable.
Yeah, you could. Yeah,
but then I wasn't sure, should I worry about calibration at the top of that, or just probably.
Is it a household survey?
No, it's I think it's in Haynes.
Oh, Haynes. Well, Haynes is really heavily post-stratified. Yeah. Age, race, sex. Yeah, you could, if you wanted to be able to say, I'm using weights that reflect what people have decided is the best way to weight the full Haynes sample, you would go through this series of steps that I talked about earlier, where you'd get the control totals as best you could by summing the weights from the full data file. And then you'd take those and use them to post-stratify the file that's got just the complete data on that one variable that's so important. All right. And if you had time and money, you could multiply impute the thing and see if the answers come out any different. All right. Non-probability sampling. In a way, we end up with a non-probability sample these days, regardless of what we do. If you're hit with response really badly, you got no control over that. So the units that end up responding are not a probability sample of what you started, at least in the sense that you had total control over who was picked. So in a lot of ways, we've been faced with this non-probability sampling situation for a long time. It's getting more publicity these days because of the curse of the internet. There's so much stuff out there that you can scrape off the web. What do you do with it? Once you scrape it off, it must be good for something. And people are thinking about how do you project it to some defined population. So, in the last few minutes, let me say a few words about that. The other motivations for the non-probability sampling are the budgets are getting tighter all the time. Even in these things that Michigan does that are longitudinal, that have been done for years, the government is getting more and more squeezed on its end for money. That trickles down to us. It trickles down to every other contractor who does surveys. Within the government itself, there's all sorts of pressure to decrease costs, so they're affected by this. And if you can easily get free data, that looks good. If you can scrape prices off the internet, why can't you just put them in the consumer price index and do it almost for free? Now, other reasons that you may want to have kind of a non-probability piece of a survey is, if you've got a special list, you may be able to supplement a probability survey with a special non-probability list. Like there was one thing Rand Corporation was doing a few years ago where they were trying to study veterans who got certain disability services. And they had, pretty good, not complete, but pretty good list of vets that did get those services. If you just drew a random population survey, you would hit very few of those people. So this was a good way to beef up that particular interesting subgroup. And the medical profession runs into this all the time. If you've got a very rare health condition, I mean, you can get cases of people that have got the condition. But if you did a general population survey, you would hardly ever run onto them if they're really rare. Things like Addison's disease that John F. Kennedy had. It's like a 1 in 100,000 incidents. And so, you can get the cases, so you'd like to use them some way. And there's all sorts of sources of various things these days. Twitter, Facebook, Snapchat, I listed a bunch of them. These infernal pop-up surveys that come up every time you hit a website. The kind of general issue is in this picture that I showed you earlier. Suppose this is the universe, this blue thing I'm trying to infer to. And just to make this more specific, suppose that's the adult population, and I've got my sample, this little green dot here, are people who volunteered for an internet panel. You didn't randomly pick them, they just kind of volunteered themselves, they picked themselves. And so you think about what the universe looks like. How did they get in this panel? Let's suppose that they visited certain web pages, something popped up and says, you want to be in a survey, you want to join your panel. They clicked the right button, they followed through, and they got in the panel. There are people who have got no internet access at all. That's this area. They had no chance of getting into this panel. There are people who maybe have internet access and they have PC. They've got internet access, but they never hit the web page where you recruited people. And then there are ones who hit that web page, but they didn't click through to join the panel. And then finally, there's this whole bunch who went through and got off the panel. I think Mick Cooper's in about 10 of these panels because he just wants to know what's going on out there. He's like a professional respondent. All right, so the inferential problem is, how do we blow this thing up to the whole target population? And does that even make any sense? I mean, you need to think through that. And, applications of big data analysis may be exactly this picture. On the other hand, if you tried to do a probability sample, depends on how you do it, you may have a pitifully low response rate. This Pew Research article that's referenced here, Kohut says that in 1997, they had about a 36% response rate to their telephone surveys, which may have seemed kind of weak at the time, but in 2012, it was down to 9%. And it's worse now, I think. And if you look at the survey of consumers that Michigan does, I mean, they're down in the single digits for the telephone response. It's just, it's everywhere, this problem. There's some APOR reports that are kind of worth looking at. 2010-13 on non-probability samples. This issue of how do you project one of these non-random samples to a population comes up in epidemiological kind of applications, also observational data applications, and that's what this kiting in Tom Lewis paper in JRSS is about. They have the same worry. So there's some examples here. Since I brought up the consumer prices thing, there is this thing that MIT still does called the Billion Prices Project. where they just, they scrape all these prices off the web every month. And they're doing it in a bunch of countries now, too, not just the U.S. And they compute a consumer price index, and they compare it to the U.S. We've got a nice CPI that's, it's an area sample, probability sample of prices in outlets and so forth, and it accounts for the mix of things that people buy. And this Billion Prices project at a big aggregate level compares pretty well to it. So, BLS looks at that and says, well, geez, I mean, these guys at MIT are doing this thing for next to nothing that we're, spending millions on every year. And, it causes some pressure down there in the agencies that have these non-probability competitors to justify what they're doing. And in the case of the CPI, I mean, they publish a tremendous amount of detail on different kinds of items that MIT can't do, because you can't scrape everything. Like prices of rental units, for example. All right, so there's some other examples there. If we go back to our picture and we wanted to estimate a total, because those are easy to think about, here's kind of what you're doing. The population total is composed of the sum of the sample. So you saw that. That's okay. And then this tan or yellowish part here, we didn't see those units. You got to predict those. And then this tan part, we didn't see those, the potentially covered units. We got to predict those. And then if you're, you're willing to go out on a limb and make an estimate for the ones you had no chance whatsoever of covering, you got to predict Y values for those. All these pieces have got to be estimated. So can you do that in a way that makes statistical sense is a big question. And I think thinking about this sort of picture is a useful way to approach, that earlier question that came in. If you got a panel, internet panel, how do you weight it? Well, what does it represent is the, fundamental question. Now, there's three approaches to this that people have dreamed up so far. One's called quasi-randomization weighting. And basically what that means is you're estimating the probabilities of inclusion for each unit in this non-probability sample. And the methods used are the same ones that we talked about earlier, especially the non-response adjustment. So mechanically, what you do is you need a probability sample. People call it a reference sample. So you combine the non-probability sample with your probability sample. You code these guys, the non-prob cases, as 1. Probability is 0. You run a logistic regression to predict the probability of being in the non-probability sample. And then you use the inverse of those estimated propensities as weights. So, it's kind of straightforward. There's technical details about, what do you use the weights in the probability sample? The answer to that is yes, but only in a certain way. Another is you just use modeling of the Y's right off the bat. Forget these inclusion probabilities. Now what that amounts to is just go into calibration immediately. You go into post-stratification, like in the internet panel of volunteers. You just take what you got, post-stratify it by, age, race, sex, education, anything else you can think of. And that'll give you some weights. And then there's this thing called doubly robust, which you do both. You estimate these inclusion probabilities, you calibrate, and then you say, well, if I got one model and the other right, then I'm correct in a statistical sense. So it's, I love this name. This is like a marvel of marketing. It didn't originate with survey sampling. The observational data people are the ones who coined the term. So they all involve modeling. Mike Elliott and I wrote this review paper in Statistical Science a couple of years ago that covers these things. All right, so quasi-randomization, this is just talking about the details of that. There's a paper that's going to come out in Journal of the American Statistical Association by these fellows at, I think they're all fellows. This one's a fellow. At the University of Waterloo. So they kind of formalize this quasi-randomization approach. And they kindly pointed out that Valiant, Beaver, and Kreuter had a suggestion in their book that gives you biased estimates with all these assumptions they made. But there's not much bias. And the couple of people at JPSM figured out how to fix it, so we're supposed to write for this. But basically you combine probability, non-probability samples together, run a logistic regression, use the inverse propensities as weights, and you're good to go. Now, superpopulation model, you calibrate, in the same ways we've talked about. And doubly robust, you do both. Now, I think the government is struggling in a lot of their surveys with these issues. Are there government people on the Blue Jeans? Census Bureau or other people?
Typically are. I don't see today, but there's typically there.
Yeah. One thing that people are trying to sort through is, suppose we have a probability sample that we think is pretty good, but we got this other source of non-probability data. Can we put them together and get something that makes any sense? And really, what it boils down to is a composite estimation problem. The obvious thing to do is just weight them together some way. 80% of the probability estimate plus 20% of the non-probability estimate. Is that any good? The things you have to think through are, does your non-probability sample only represent part of the population? I mean, if you're going to weight it, how far do you blow it up? You may not want to weight it all the way up to the full population, especially if it's a specialized group of people who are, the veterans who are getting a certain kind of medical care. They only represent other veterans who are getting that kind of care. So you wouldn't want to blow them up to all disabled veterans. So you got to somehow solve that thought problem. All right, there's some references, and here's what we covered. Basic steps, weight calibration, non-probability sampling. That's about it. So this is your last chance for questions. Yeah.
So on that approach that you had like a few slides ago, usually we have like on the benchmark survey, right? Like you're gonna use some covariates, like you're gonna combine the benchmark survey with the non-probability survey. You're gonna run that logistic regression, that kind of like logistic regression model.
Mm-hmm.
But usually the variables that we have on that survey, it tends to be the same variables that we have calibrated, right? So like my question is like, is there any advantage in doing that double robustness approach if the variables they're using for the propensity model are the same that you would be using to calibrate for the superpopulation model?
Yeah. Yeah, good question. I mean, so Raphael's asking, what is it worth it to go through both these steps to get doubly robust if in the end you're going to calibrate to get things sort of adjusted so that your sample looks like the full population. The argument for doing it would be the same as, why do we non-response adjust a probability sample and then we go ahead and post-stratify? Why don't we just post-stratify and say we're done? And the theory that would support that post-stratify only would be that it takes care of both non-response adjustment, coverage adjustment, and reduces variances all at the same time with that given set of covariates. So that, if there's an argument for doing all three of these, or this followed by that, it would be that you need a slightly different set of, different model for the inclusion probability estimation than you do for the calibration. And if you don't, you could just do this. Anything else? Any chat room questions?
No problem, clear on chat questions.
All right. Well, thanks for coming.
Great.